Hello, everyone. Welcome to another episode of Training_Data. I'm Anna Venetin. I will serve as a poor substitute for Ryan Lewis as the host this time. But this is an exciting podcast. We have a high percentage of the cosmic diaspora with us. So I'm joined by Daniel Hogan, Jake Schirmeyer, Ryan Lewis, Nick Weir, and last but not least, Lisa Porter. And I'll let each of them in that order just say a word about who they are. So Daniel.
Hi, I'm Daniel Hogan. I joined CosmiQ Works at the beginning of 2019.
Hey, I'm Jake Schirmeyer. I was a research scientist for CosmiQ Works for about 3 years. I've since moved on just about 2 months ago, and I've joined Capella Space. There, I'm a data scientist.
Yeah, I'm Nick Weir. I was with CosmiQ Works for about a year and a half, and about a year ago, I left the team and joined Professional Services Group at AWS.
The prodigal son returns. It is a privilege to be back on Training_Data. I have noticed that the episodes have become more rich and more compelling in my absence, but it's a pleasure to be back. As the Radiohead song says, everything is in its right place, and it is good to see all your faces in these little boxes for today's conversation. Ryan Lewis, I was with CosmiQ since the beginning in 2015, and I left in September of 2020 and have been working with AWS in the National Security Space since. So looking forward to today's conversation.
So I'm Lisa Porter. I joined CosmiQ in the fall of 2015, and I left CosmiQ in the fall of 2018 to go become the Deputy Undersecretary of Defense for Research and Engineering. And I left that job in last July of 2020. So I am now, myself and my colleague, Mike Griffin, have a small consulting company called Logic, inspired in part by CosmiQ. And that's Logic, not Logic Q. And it's CosmiQ, not CosmiQ. Those of you listening out there, still getting that wrong.
Yeah, it's constant. Yeah, well, it is fun to have everyone here. We anticipate this being the final podcast for Training Data, which is tragic, but it's fun to have everyone here. And so this kind of serves as a chance for us to talk about a lot of the wins that CosmiQ's had over the years, especially SpaceNet. We'll reserve most time for SpaceNet kind of towards the end, as there's so much to say about that. But just kind of jumping in to some of the things that really founded CosmiQ. So I wonder if Lisa and Ryan maybe just kind of weigh in on what was the beginning of CosmiQ and why was this formed?
No, it's a great question, and given how far the whole team has come, and certainly for the work everyone did on the line over the years, and also for those that couldn't join. So today, such as Todd Stavish and Dave Lindenbaum, it's sometimes hard to remember kind of how we got started and why. But really succinctly, when the concept of CosmiQ and an applied research lab that focused on the intersection of commercial space and aerospace and machine learning, it really goes back to our IQTL's first look at the commercial space sector and what were going to be primary drivers for the consumption and then increased collection of more space-based and airborne data. And a lot of the discussion kept coming around advanced analytics, and that advanced analytics would simplify the ingest for either public or private sector stakeholders to consume these data, draw insights from them, and then in a virtuous cycle, request more information. And while on paper that sounded great, what we found was that it was really hard to start picking out particular requirements, right? And these are really simple questions that are really hard to answer. And in fact, they are so challenging that they're still relevant today. And so very basic questions such as what resolution requirements were necessary, how many collects over a certain geographic location were necessary to answer questions, what type of analytic performance was helpful for certain applications. All these things were sort of question marks. And for us as a strategic investor, and for us as a contributor to the overall technology community, we found that we needed to do something a little bit more than what was in our traditional investment model, which was having a high impact in the sector, but wasn't always necessarily picking at some of these questions. So our goal early on was, even before it was a lab, was how can we structure sort of an applied research setting where we can start trying to answer some of these questions, or at least put bounds around them, right, in terms of quantitative research that can help inform the government, help inform startups, and then help drive the community forward in terms of building products with high impact. And so that's really how the idea came about. And like all good things, it evolved rapidly over time. And so with each person that joined the team over the years, they brought their own insights in terms of subject areas we should focus on, different model architectures that we ended up deploying and open sourcing. So while that core idea has been a driver over the years, one of the things that I take a lot of particular pride in is looking at the mark that each person had in terms of the work we've done or impact we have with customers.
So I guess I'll add a little to that. So Adam, you probably recall you and I joined only about a month apart in 2015, end of 2015 timeframe.
That's right.
And so when I came on board, you know, Todd and Ryan had already done a lot of the heavy lifting of just setting up CosmiQ inside In-Q-Tel. And it was a very disruptive idea inside a disruptive organization, right? So a lot of people were trying to figure out what it should be, including our boss, Chris Darby. And so when I came on, he said, hey, can you work with these guys to sort of focus the team? It's a small team. I'm not going to go out and hire 50 people. So, you know, how do we actually have an impact in this really rapidly evolving dynamic space, right? CosmiQ was trying to address a huge amount of different things and looking at a lot of different aspects of commercial space. And Ryan, you may remember, and Adam, you would probably remember too, in the very early days, remember we had that overarching framework and it was just one slide where we kind of sort of broke it down for the community to say, look, these are the different subsystems that we have to think about when we talk about commercial space. And it was funny. Do you remember how many times people were requesting that? We would brief it and people said, can I have a copy of that? And we were thinking, geez, don't you guys already think this way? And I think
still got referenced in a meeting recently. Someone's like, hey, look at this chart. I'm like, oh my Lord.
It was a really nice,
it's still alive.
It really represented, you know, the sort of ecosystem, and it allowed us to explain to other people, to your point, Ryan, you know, here's where we're going to focus and why. And for the analytics, of course, you know, that was an area where there was a barrier to entry that we realized we could help break that barrier down. So as a small team, and we were so small, and you guys have stayed small all along, you know, you can't boil the ocean, to use an overused phrase, but you can pick certain things where you can have tremendous impact. You know, we used to say, you guys remember, we'd say we were punching above our weight. We were trying to make sure we were doing things that would really move the needle. And SpaceNet kind of evolved from that. And I will share a story because Dave's not online, so I can embarrass him. SpaceNet in part came about because Adam and Dave and I had gone out to San Francisco to meet with some portcos. And we were a little dismayed by the lack of number of analytics companies to even look at in this domain, right? And Dave and I were kind of venting, and thankfully he was driving because I'm not a good driver. And we were driving back to the hotel, and he and I were just kind of complaining back and forth about what's going on. Why aren't there a lot of companies jumping in on this? And then we realized, of course, the eureka moment, well, there's no data for people to train algorithms. And there's a whole community of data analytics folks out there that are working with ImageNet now, which had been huge impact, as you recall, in 2015-16 timeframe. But people weren't understanding, well, there's a whole new set of data that we need to learn how to analyze. And that was kind of the genesis of SpaceNet, had been sort of swirling around in all our heads, and we were able to crystallize it. So thanks to Dave and his good driving, his ability to allow us to brainstorm in a car in San Francisco, that was kind of the beginnings of SpaceNet, as far as I recall it. So I thought I would share that with y'all, because I think you all know, most of you know that story, but I can embarrass Dave because he's not online.
The origins of most of our work usually take place in rental cars or in hotels somewhere in San Francisco. The space architecture that you referenced was developed in, I think, the unofficial headquarters of CosmiQ for a while, which was the SFO Airport Marriott. Shout out to the Bonvoy Club there. Really great place if you're looking for a free cup of coffee. That's where we built the original architecture as well. And it is amazing that all these years later, that a lot of these core concepts still ring true, whether it's taking a systems level approach to understanding a particular problem, or in the case specifically of machine learning, the dearth of training data for particular applications. A couple of us were just texting about this morning. So certainly timely topics that I think in some ways, right, as a collective, I'd say we were ahead of the curve in some ways.
Most of our best ideas also involve embarrassing Dave.
Yes.
That is true. Well, thanks for that kind of setup, Lisa and Ryan. So I thought now we might take a trip down memory lane and dive into some of the key projects, which really, since we have this framework that Ryan and Todd and Lisa kind of set up for CosmiQ, then when we had people come on subsequently, like myself, Jake, Daniel, and Nick, we can dive into these projects. So maybe just I'll just pick a kind of a few. We have a lot we could cover, but just in the interest of time, maybe one to start with is the commercial remote sensing survey, which unfortunately, again, Dave Lindenbaum was supposed to be here. He's probably solving actual problems rather than chin wagging, as Ryan likes to say. So good for him. So he was instrumental to this. Especially, we had a couple, but maybe Ryan and Lisa, to pull on you again, like that was very impactful, and I think it really helped set CosmiQ up for getting kind of people's interest later on with the projects again that the rest of us really were working on. So maybe just a note about that.
So Ryan, you want me to set you up here on this one a little bit?
Sure. I'll you're the leadoff hitter on this one.
All right. So, this is really interesting because Ryan and I are both what I would call skeptical optimists. And I think that's a good thing. I wear that badge with honor, and I think Ryan does too. We have enough background in terms of business and economics. Ryan's very deep, as you guys know, in understanding economics. And so when people present us with funny math, we kind of say, I don't understand the business case. So our perspective inside In-Q-Tel was looked at a little askance by some of the other colleagues we had, because they'd come in and they'd pitch raw water. I'm kidding. In-Q-Tel never bought into raw water, but that was a thing, you guys remember, right? And Ryan and I would always ask, okay, but how is this actually going to make money? Can we walk through a business case? And so when we were looking at commercial space, as much as we loved the thesis of, hey, what if you could, really drive down costs through significant cost innovation and open up a whole new set of markets potentially in this domain, when we thought it through, we said, at the end of the day, it's still a lot of capital. It's still a lot of hardness. Like space is just hard. You can't commoditize system engineering, and so he and I had sort of that realism perspective. And we said, we really need to look at this with a very objective perspective because, and this is why it was so important in all seriousness, our customers were assuming that commercial space was going to evolve kind of independently of the government, that there was going to be a huge market driver that was outside the government, and then the government was just going to be able to swoop in and buy it by the drink. And if that hypothesis was wrong, then there wasn't going to be anything to buy. And so that was the concern that Ryan and I really had as we were looking at remote sensing and the markets and understanding, particularly with SAR, which is a very complex and expensive undertaking. What does the government actually need to understand, and where might it need to focus some investments to essentially accelerate this market rather than just assuming it's going to be there? And I will tell you that this mindset and the work that Ryan did, and I don't mean to embarrass him, but it was so impactful to the government that you even see impact of how he and I worked through this together in things like the DoD's current strategy with proliferated LEO. So the impact that CosmiQ's thinking has really resounded in ways that maybe you guys don't even fully appreciate, where there's a recognition now that the government actually is the anchor customer for what we call commercial space. And there's nothing wrong with that. That's still a win-win. That was what Ryan and I were trying to share with the community. Look, guys, it doesn't mean it's a failure if the government is going to be the near-term lead customer, but you need to recognize that. And you need to think about how you accelerate what's going on and help to bridge that really challenging gap for these companies, especially the hardware companies. So Ryan and Dave did a tremendous job really diving into the SAR in particular, although broadly the commercial market as well. And Ryan, you'll talk to that in a little bit. But the SAR in particular really resonated because there was a tremendous amount of irrational exuberance, frankly, around, we're going to have $1 million a pop SAR satellites that were going to provide value. And, we sat there with the physics, and we sat there, and Ryan and I believe laws of physics, laws of economics. These are two things you can't get away from. Adam, I know you think they're just guidelines, I know, but really they're laws. And so we were trying to tell people, look, you got some, sort of constraints here. You got to think smartly about this domain. And I think the SAR work that Dave and Ryan did, the broader commercial market study that Ryan and I worked on very hard, and then later the SATCOM study that Ryan worked on. I can't tell you guys just how impactful that one was to our customers, even today, to this day. It was referenced on a call I had yesterday with another client. So the thinking that went into that was just really about, let's be realistic about the market here, because the government is going to rely on this innovation. So it better not do things that it doesn't mean to do, but that ultimately kills that innovation, because they're just sitting there expecting a separate market to evolve independent of its actions. So Ryan, with that, I'm going to hand that over to you. And I didn't mean to embarrass you, but people talk a lot about SpaceNet, which we're all very proud of, but I think sometimes they don't realize that the market assessments that you did, which were informed by technology and physics as well as economics, that's what made them so special. Those had true impact at senior government levels. And the influence there is more indirect. It's hard to see it sometimes when you're in the middle of it, but I'm telling you guys, from where I moved since In-Q-Tel, the impact has been profound. And Ryan and Dave in particular have a lot to be proud of there. So not trying to embarrass you guys, but I did want the world to know that.
Well, I really appreciate it, Lisa. And it's in looking back at it and in preparation for today's discussion, I was looking back at just some of the text chains early on, way back a couple of years ago, and just the amount of dialogue between the whole team, certainly Dave and I, but the whole team as well, and with you about, do we have this report? Do we have this? Can you look at this? So these numbers make sense. It's a non-trivial lift. And it was the amount of support we had also from the broader investment team to help us pull the information, particularly Tom Gillespie on the investment side. Really was a whole group effort. And I think at a macro level, Lisa, you hit on this, but just to foot stomp it a little bit, one of the things that I look back at particularly fondly is that it's really cool when you're attacking a problem and you're kind of coming across a lot of first, right? Like the first time we think about a systems of systems approach for a space market, the first time, right, we think about how would we create or how would we assess in some sort of economic value the collection capacity of a SAR satellite, assuming there's a machine learning component. We all did that in our own ways over the years, and that part I think is something that never grows old. Is the fact that you're trying to figure things out for the first time. And I know whether it's the remote sensing market analysis, certainly the SAR trade study, and then as well as the commercial SATCOM piece, trying to take a holistic view for investors, but then as you pointed out for the government, I think it's really cool because most of the time, like particularly in the analytics space where so much of our work over the years has been, right, you look at the application level and you're trying to figure out, does this thing work? Does it fit into an existing workflow? And what does it need, right, to reach some level of maturity or development level? And in this case, it was different because machine learning was certainly a huge component, but it was just that. It was just a component. And for us to go and say, if you want this whole thing to exist, you're going to have to make strategic investments over time in order for them to reach some level of maturation. And I think it's really cool that we're actually starting to see that now, like where the work that everyone on this call is doing, the work you did and are doing now, and then even with Jake now actually working at a company that is an embodiment of this strategy over time. It's cool to say all of us influenced it in our own way, and we all played a little bit of a part. Lisa, you actually played a huge part at the Pentagon, but also at Cosmic, we all played a little bit of a part. So I think that's really cool. The only thing I'll add is on those studies, I think particularly for the SAR trade study, a little bit on the remote sensing piece, is that one of the things that I'm still biased. I love it. My first bias, I think, will probably always be in geospatial or in commercial space to some extent, is that in a lot of analytics problems, there's usually like some corpus of data, right, that you're going to work on, and we're trying to figure out what to do with it. Well, space is unique, or aerospace in general is also unique in that we have analytics, but then those analytics directly influence very complex collection process that can be, in some cases, very expensive, right? So there is a direct effect on other very, very critical, complex, expensive mission tasks. And one of the things that I think is still cool is that I still draw on lessons from all of our original analyses today when I'm in conversations and we're talking about how much data do we need? What's the resolution requirements? Always going back to those core questions. They're just as timely now as they were then. And I was just in a conversation recently where someone's like, hey, well, what's the right evaluation metric? And I was like, well, it really kind of depends on what question we're asking. And then depending on that, we'll have a better insight on how much data we need. So it's cool to see that different companies are attacking this problem since our original studies.
Yeah, no, thanks for that. Those points. I think you guys highlight a lot of the positive. I mean, there's another aspect which might be perceived as negative, but I think it's still a positive, which is, and you guys already touched on it somewhat, which is like those market surveys really induce some panic in some people, right? And in a good way. So the attention that brought, again, I think kind of let the rest of the Cosmic team run a bit. So certainly we appreciate that early setup. So let me pivot then a little bit to some of those actual kind of more data sciencey projects, which were enabled again by the traction that we had. And I had a few things here. One of the projects we worked on earlier, we called YOLT, because making up names is my only real skill or affliction. I'm not sure which one it is.
Adam, can I ask you a question?
Yes.
Could you tell me about YOLT? Why is it important? What motivated you to do this work?
Well,
and why didn't we make a T-shirt about it? Save the hardest question.
We should have made a T-shirt. That last one I have no answer for. No, I don't want to spend much time on it because I think we have actually more interesting things to cover. But this was a case where we had some ideas on things we want to investigate and realized there's no actual tools to do this, right? And so originally it was just, let's make a tool to find objects because that's kind of where you start if you want to do something real. And it turns out we did this and it worked better than we hoped. And actually we know some of the leading commercial companies use it as a benchmark. So that was kind of fun, right? And so I think this is kind of indicative of a lot of things that we do, but I'm gonna throw a curveball in here. And I think what's actually more interesting than YOLT was Solaris. So I know this isn't on the schedule for everyone who has it for them, not the listeners, of course, but I think it's a good thing to talk about. This is something that Nick really pioneered, and there's a lot to say about it, I think, because there's a whole pipeline that Nick built. But I think it also plays into one of the things that Ryan and Lisa mentioned that we really put a ton of effort into, which was the metric piece. So a lot of people have built some different quality of tools for pre-processing data for geospatial. And then a few people, not many, have tried to build ways to train models, but very few people have actually put a lot of effort into actually evaluating that in a meaningful way. And so obviously, Nick, it was your baby, so you can disagree with me. But to me, I think just that piece of build us a robust software suite so we can do analysis and get real results and not just throw a pretty picture up there. that to me was a lot of the win. But over to you, Nick, for kind of if you have anything you want to add about the Solaris effort.
Yeah, no, I mean, that was a great project, and I appreciate the kind words on that. I wouldn't say that I pioneered it. I really picked it up off of great initial work that Dave did to build a lot of our initial tooling.
That's a good point.
And then, but it's certainly true that there are a lot of people who put together great model implementations, great pre-processing pipelines for computer vision on satellite imagery. But stitching together all those different pieces is kind of essential to be able to compare algorithms against each other, right? Because we know that pre-processing is super important in terms of how satellite imagery, object detectors, or segmentation algorithms work. And if you are kind of mixing and matching pre-processing pipelines and algorithms and then trying to compare results, it just doesn't really work. And so that was kind of part of the impetus for building out this tooling, was we wanted to be able to generate really good apples to apples comparisons of say road detectors using the Apple scoring metric. So that was a great project for me, and I appreciate the shout out.
Well, everyone on this call, right? The pretty modest group. Adam, I skimmed over, I think, one important thing, which is with YOLT, which then kind of laid the groundwork for a lot of our other efforts. YOLT was really our first foray into developing a model, evaluating the models, figuring out what was interesting, how to report it, and essentially really influenced a lot of the other work that we ended up doing, which then became model development for SpaceNet, which then built out our SpaceNet utilities, which then, as Nick was highlighting, then really led to Nick coming along, building off what Dave did, and laying the groundwork for then what it was, Solaris. And this isn't maybe a particularly unique observation per se, but it's certainly one that I had, is that oftentimes, like, one will look at like an end state and they'll say, man, I really want, a robust applied research group that's doing machine learning in X. And I want this in some period of time. And I think one of the big takeaways I took from all this experience and working with all of you over the years was that it was really an iterative effect, right? Like, it wasn't like we could just jump right into a complex road detector or a SAR analysis or synthetic data analysis, like what you did, or Nick mentioned Apple's average path length similarity, the metric you did, right? Adam, optimizing routing. All those things were desired states, but a lot of it were in the early stages were just baby steps about what do we know about one type of model on one type of data. All right, what does that tell us? All right, what's the next step? What's the next step? And although it's not always the most exciting tagline to say we are incremental, right, in our innovation, I think it is essential in any market, perhaps, where you're having such rapid advances. It's hard to make sense of what is or is not interesting. And I can't take credit, right, for that strategic development, but I can say I was glad to be a part of it. And I think it's something that we did really well over the years, and it speaks to everyone on this line that everyone kind of figured out what part to pick up and drive and where to go next. And I don't know like how you capture that in an organizational structure, but it's been really cool to see unfold. So Adam, thanks for getting the original some of the original work kicked off. I actually reread all the original histogram oriented gradient hog and then the original YOLT papers last night in prep, and in blog posts. They're still good. They still hold up, right? Just like an album like from ELO, still solid all these years later. All right, Jake, I'll turn it over to you now. Sorry about that.
All right. Yeah, I just wanted to kind of piggyback off of what Nick said about Solaris and some of Ryan's comments as well, just in terms of how releasing software like that in the open source really allows you to continue to develop and incrementally build things that probably weren't possible and do it really fast and at speed. So, I mean, I used Solaris throughout the whole RarePlanes experiments and data science project that I'll talk about in a little bit. But I'm still using it today, right? I'm using it in my job. So that means it's not only enabling just what we did inside of Cosmic, but also, it's helping companies in this geospatial domain really continue to advance and advance their analytics forward. So I think it's been super impactful, and would recommend that to any data scientist out there and that's involved in this space.
And Adam, if you would let me pile on just for another minute here on this topic, because you and Todd, who's not on the call, people forget way back. I'm going to take you guys way back when we started SpaceNet, and we were working with different platforms to try to figure out how are we going to set up competitions with metrics. And at the time, ImageNet was the only real model that people had, and ImageNet used mean average precision as its metric, which makes sense if you're developing, query kinds of software where you like every image I get back has to be a cat. So my precision has to be really high. It doesn't make as much sense for our intelligence community customers who are like, well, I can handle some false alarms as long as I don't miss any of the missile launchers I'm looking for. And so Adam and Todd, and I got to tell you, I mean, it was hard as hell for these guys to, convince this community that was wed to, well, ImageNet did it this way, so this has got to be the metric, the gold standard, to convince them that, there are other metrics that matter. To Ryan's point about what is the problem you're trying to solve, that will drive the metrics that you have to establish. And so now when, when you look online, people are all talking about the F1 score. When we started, Adam couldn't even get something published until he agreed to include mean average precision in addition to the F1 score, because they were
I forgot about that.
Oh, I didn't forget it, because I think this is.
I forgot about that.
I think it's a really important point. You guys have had such an influence beyond, as Jake was just saying, beyond the internal of InQtel, which has been a tremendous influence. You've had a huge influence on the entire community. We refused to compromise on this. And you recall, Todd, myself, Adam, we were arguing with these people. No, you guys have to understand it depends on the problem. And we finally got everyone to agree. And now, of course, everyone cites F1 score like they all thought of it from the very beginning. And so I enjoy that story because it's so important for people to realize that some of these things that, Ryan, you use the word incremental. Sometimes I use the word, unsexy, because it's the stuff that really matters, right? I don't care how cool your pretty picture is. Like, that's nice for the front page of some article, but what does it actually mean? Right? How do I actually use this technology? And that's what Ryan and I and Adam and Dave, Todd, we were all trying to say, is this going to make a difference? And how do you know? And you can't know unless you have a way to measure it. And you guys have done so much great work. And then, of course, Apple's, where F1 wasn't good enough for that one. So we revisited the question. And then you guys continued to do that after I was gone. And I think that was so profound. And I'm telling you guys, you should just be really proud of yourselves for what you've done, all of you, in terms of not letting that, not letting go of that, not compromising on that theme. It's really important.
Yeah, thanks, Lisa. I think another thing is another colleague who couldn't make it, but was actually instrumental, at least in the initial metric, was Patrick Haggerty. Right. So that's something also.
Yes, Patrick as well. That's exactly right. Patrick, Todd, you, me, we were fighting like heck to get people to just say stop with one metric because it's whatever. Well, this is what everybody uses, right? Well, what kind of argument is that? So, yeah.
Yeah. And then another thing that I'm at least thankful for, and I think everyone else agree, is that, well, a little segue, but related is, the first few blogs we wrote back for the downlink, right, for Cosmic's blog, I remember thinking that this effort is comparable to like my archive papers back in grad school, because Lisa was really adamant that, like, look, we're going to be real careful what we say. We're going to really be diligent, and error bars. If you don't have error bars, go home. And I'm very thankful for that. And I think it served us very well of being really forced to really be diligent technically. And again, like, you still look, computer vision papers, error bars are very rare, right? And it's kind of horrifying, frankly. But they're not super rare in the CosmiQ Works. So thanks, Lisa, for driving that home, which has been good for us, like I said.
Well, to add on to that, nothing is complete without at least one Lisa story. And I remember, Lisa, this was not long after you joined, and Adam, you were on board, and I remember we were reviewing one of the 3-part series reports that we did, and those became the original Hog blog series that we did, the original post that Adam's talking about. And I remember I was sitting down with you and we were reviewing it, and I was like, well, this is more diligent than most papers we can find. And you're like, I don't care if they're more diligent than other things. We have to be clear. And I was like, I still think of that even now when I'm putting something out. I'm like, well, this is pretty robustly cited. This is good. I'm like, does it meet the bar though? And the answer was, it should always, right, try to meet the highest bar. And I think that's one of the things that when we always got feedback, whether it's blog posts, certainly the papers that we put out at conferences, not so much training data podcasts, but maybe that's because I was more directly involved with that. I can see a couple of people shaking their heads, so that's about right. But outside of that, I think that was always one of the gold standards that we were recognized by, and you had a huge part to play in that, Lisa, and setting that standard early. So thank you very much for all of that.
Yeah, why don't we go over kind of one more of our projects? Again, we have lots we could cover, but let's highlight RarePlanes briefly before we get into SpaceNet. And so this was one that I think actually, like a fair number of our projects in Cosmic ended up having longer legs than we expected. And so Jake, maybe just briefly kind of what the goal was, and then really what do you think the final takeaways are of this data set and the effort?
Yeah, so RarePlanes was turned into a labor of love for me. It was certainly consumed a large amount of my time, probably about the last year and a half of my time at Cosmic. And I mean, I think it kept growing and growing as we got deeper and deeper into it, as things do. But the whole takeaway was really examining the value of synthetic data for an overhead perspective. So we've seen a lot of synthetic data being employed in traditional computer vision settings. Could we actually build a data set and test the value of synthetic in this overhead perspective? And our focus ended up being on planes. So can we build synthetic data for aircraft, and does that help you boost performance for certain applications? So we partnered with a company called AI Reverie, and they're a startup focused on generating synthetic data using gaming engines. So we partnered with them, built this great data set that included both real satellite imagery from Maxar's Worldview 3 sensor, as well as the AI Reverie synthetic data. We hand annotated all of the Maxar scenes for different types of aircraft, as well as their attributes. So like when I say attributes, it's like the type of aircraft it is, the number of engines, the type of propulsion. Can we build detectors for each of these, minor tasks to try to find, different planes with different attributes? But the real value of synthetic that we were trying to examine here was, can it help you detect rare objects where you have limited training data examples? So say there's a particular type of aircraft you're really interested in finding, and you really only have a few training data examples. Can you augment your training data with synthetic? And does that actually help you boost your model's performance? So I ended up constructing several experiments around this. And our findings were pretty interesting in the sense that it does help you when you have very few training data examples, so say like less than 10. Synthetic data can be very helpful. But as you add more and more real data examples, it certainly becomes less valuable. So that was a good lesson learned, I think. I think there's a lot of work still to be done in this space in terms of examining the value a little bit further and a little more in depth. But it was fun. And another thing I want to say about RarePlanes is it's actually an open data set, kind of in that SpaceNet style. So we open sourced a combination of the Maxar scenes and the AI Reverie imagery. That's all hosted on AWS3 through their open data program. So anybody can go download this data set and work with it today. And we think that's important for kind of continuing research and innovation in this field and starting to understand the value of synthetic a little bit more.
Yeah, and I think that we know that data set is of high interest to multiple people, and the results too. So that has been very successful, and there's active interest now, which is also cool. We don't need to go into details there, but yeah, that was an impressive project for sure. Go ahead, Ryan.
And just to add on to Jake's comments, in that the end result of the data set and the associated work, right, as you were saying, Adam, right, still has legs. I mean, even in some things that I've looked at, right, we've used the data set. I think the thing that I remember best about the project before it was the dark times for Jake in terms of curating the data set, where we needed to have some forced vacation time for him, was, and it kind of goes back to this point we're making across a lot of the different topics today, is that there was still like a heavy focus on what one would call really foundational issues in machine learning or data set curation. And it sometimes gets overlooked, but Jake and Reverie and the broader team at IQT spent not a non-trivial amount of time, months, just clarifying what we even meant when we said we were going to annotate aircraft on overhead imagery, and what sub-features mattered, what sub-features did not matter, and how we could at least prove that in some exploratory data analysis. And sometimes that gets overlooked, right? Because we immediately want to start looking at the model performance or the rock curves once we have the data set complete, and that is exciting. But that huge chunk of the project, before we even really kick things off, so to speak, was even figuring out what labeling taxonomy makes sense, right? And that took a lot of different stakeholders to come to an agreement. And I think that's where, even today, with a lot of machine learning projects, all of us work in it in some capacity, a lot of the magic, so to speak, is still there when you're starting with a new topic. So it was a huge lift to Jake and the rest of the team. And I think that and early diligence is one of the things that set a good foundation for that project and enable it to have such an impact that it's had.
Yeah, and Ryan, the point you're making about data curation and the upfront work, it had such an effect even on me, even though I didn't have to do it. And I'm gonna do a throwback memory for you. Do you guys remember when you were in the kitchen? Because our area right downstairs, and it was sort of the little cosmic corner of the kitchen. And poor Dave Lindenbaum was doing the equivalent with ships, if you recall, and having to label, and trying to figure out on these little tiny pixels which way it was even facing, right? And oh my goodness. And so that really impacted my thinking about this domain so much that, again, the influence that In-Q-Tel has had outside of In-Q-Tel, right, in terms of getting people at the senior levels to understand, it's not just press the little button that says, okay, press and the model will churn on data. How are you getting all this data prepared? That's where a lot of the real blood, sweat, and tears comes from. And all of you guys have experienced it firsthand. and if you haven't really seen that, you take it for granted and you assume that Google just has this magic, machinery of awesome data, and you don't see the little guy behind the screen, right? The wizard behind the screen who's cranking out all the manual effort to make this data work for these algorithms. That's a profoundly important point that I think Cosmic has been able to share with the broader community. Again, part of why I wanted to join today is I wanted all of you guys to know, based on where I was lucky enough to go from Cosmic and the interactions I've had at senior levels, how much impact your careful thinking and your diligence in this space has had. Because you don't know you're necessarily, right, if you're in the middle of it. So I just wanted to share that with you. But I also I'll never forget that image of you guys sitting down in that kitchen and poor Dave pulling his hair out trying to label boats in the middle of the ocean. So.
Wait,
Oh, Dave's here.
Is the one and only here?
Yes. Dave, you're on.
Dave, you're here. Awesome.
I'm here for 5 minutes. And just in time to, I think my lesson learned from that, and it holds true completely, is you're almost always labeling data at least 2 times, if not 3. My rule of thumb is you label data once and it's bad. You get at least one more try to label it a second time. And then you really want to do it a third time and no one ever lets you do it. But I'm here. And it's, that was like a really good lesson learned on the fact that what you think is being a clear thought is not always clear. And what you really want out of the data. I think for us, the first time we labeled the data, we just put a a dot in the center of each boat. And then we drew a box around the boat. But what we really wanted, then we drew a line on the boat.
No, it was the line. It was the line first. I remember we thought we had solved it. We're like, oh, this is done and dusted. Let's move on.
The line was still a great idea, though. I mean, that actually had a lot of legs. It was great.
That legs, but we wanted the width. We needed the rotated bounding box. And
couldn't get the width.
But we weren't going to lay that more time. Yeah. And then, I mean, I think later on with going back to the RarePlanes, the fact that moving on to that diamond gets you there really well.
Yeah, the diamond was critical. So again, building upon past lessons learned here. But yeah, I think one of my favorite Space Club rules is you got to pay your tax, just not every day. And when you're in that label grind, you're paying some tax. But it's worth it, because I think if you've got a model, it's garbage in, garbage out. And if you're throwing garbage in your model, it's not going to work. So that's really a critical aspect of the whole machine learning pipeline. And
you're paying that tax every day for a couple months, unfortunately. So you do kind of have to break the Space Club rule, at least for a little bit of time. One of my, not to turn this into too much of story time, but one of my, Lisa mentioned in the kitchen when we were banished there, and then Jake relived this with RarePlanes, and then Adam relived this with a couple of times on SpaceNet, and Nick relived this on SpaceNet 4. So it was kind of a reoccurring movie. It was essentially like the endless Jurassic Park series. They just keep coming. But I remember, Dave, remember in the kitchen we had the motion sensor lights, and they would click off after, I think it was like 15 minutes. And someone from the cleaning team came on down. It was like 8, and the lights had been out for hours. None of us had moved. And I remember they came in and go, "You guys need to get some sunlight and to move." They sat there all day just looking at pictures. It was a dark time, and it became almost humorous to me to hear over the years everyone on the team go, "God, this is just awful. Isn't there any better way to do it?" to do it? And there's no substitute for hard work and experience, unfortunately. So it's a good lesson learned that we learned almost every year for the last 5 years.
Yeah, definitely. Why don't we pivot to kind of the last item on the menu, which is the SpaceNet, right? We've already referenced it multiple times. Again, this is, I don't know if it's a chicken or egg, but the way that SpaceNet unfolded is intertwined with kind of the way Cosmic operated, right? And so again, a lot of this we've already touched on, the way we thought about it. But maybe just since we have Dave briefly, since Dave was critical Dave was really the guy behind the scenes initially to make this all happen, right? There's no way it would have actually gotten off the ground without a lot of people's work, but certainly Dave was the one doing the grind, paying the tax for SpaceNet 1 and 2, et cetera. So since we got you, Dave, what was the most interesting and difficult part of that for getting it spun up?
I think some of the more interesting parts was, amazingly, this was 5 years ago, and just combination of thinking through the strategy of how to host it and create it. So we did a lot of that early tax of taking large TIFFs, large satellite images, and breaking it down into something that was competitive or that could be parsed in. And it was a lot of iterative process of understanding all the nuances, and we learned a lot from it. I think even just learning the differences, trying to understand how to push this together from both sides on this for example, we originally on SpaceNet 1 wanted to test geographic diversity. So we specifically had the validation set be completely separate from, in a completely different area of Rio than the test set. And we learned something interesting there. There was a real big problem at the time, and it was a very different thing. But maybe we didn't want to learn that way. We didn't get as much information out of it as I think we could have restructured. And so SpaceNet 2, we went to more of a random approach. And then I think back when you moved into, I believe it was SpaceNet 5 or 6 with the hidden city, you finally got to learn that again, but you had enough knowledge to actually go that far. So it's kind of figuring out how far forward to push the data process. But it was really interesting to learn different mistakes along the way of, we had one of the more interesting one was closed or arenas. So if you take an arena and it's a closed circle, the real hard part of this is, you want the inner part, the grass, not to be part of it. And that was like an interesting edge condition that for about, a month we didn't catch until someone pulled up an image. It's like, this is wrong. You're like, oh, I know how to fix that. But it was like an extra part of it. And so it was really interesting just to learn along the way of how to produce it. And then I think really interesting is how the whole geospatial community has come out of using cloud native technology to host things and build things. And it's all about, stack and cogs. And now things that where we had to download large tar files, we can now just kind of stream it from the internet. And it really opens up this whole compute environment that makes it really interesting. So really kind of, that's been exciting to see it move from like a really static environment to what potentially could be really fearful and in cloud. And that's it. Yeah. I apologize. I've got to run actually, but really nice to call in with everyone. Great to see everyone.
Thanks for calling in, Dave. Yeah, it was, I remember that split that Dave did for the first SpaceNet. And that was actually, it was a huge battle, frankly, with people we were working with. Like, okay, we're going to have a second test set that no one's going to have access to. And that's going to be the final score. And that's standard now. But it was a huge battle in 2016, which was kind of shocking. But like that is so much, I think, again, things we've influenced. Everyone does that now. But it's just like the metric back then. It was like, why do you need to do that? That's not necessary. You're just making it more difficult. No, it's very necessary. It's very necessary. So again, that is, I think, some of the things that Dave, along with the rest of the team, really had an impact on. Why don't we have we keep talking all day about all this. We've talked a lot about, I think, about kind of the impetus for SpaceNet, the data set being necessary. Actually, at least you had a good point you brought up earlier about kind of why we specifically wanted to start with this data. So maybe a note on that, and we can dive into the specifics of certain challenges.
Sure. Yeah, I think as you guys all recall, ImageNet, at that time, it was really an exciting time, that 2015, 2016 timeframe, because that's when the competitions from ImageNet were really producing results, and it was really fresh. The difference between 2012 and 2015 was enormous, right? And it was all because of this data that was available. And we really wanted to see that kind of success, frankly, applied to imagery from space and data from space. But we started with imagery. And I think that was, we were very motivated by all of what we learned about ImageNet and how it was done. And we said, well, we don't have, 7 years to put a data set together, but we certainly have, if we're smart about it, we have some partners that maybe we can convince would be a win-win if they were to provide that data for, essentially make it publicly available. And as you recall, our first partner in this it's now Maxar, but it was Digital Globe at the time. And I think we should give a shout out to Tony Frazier, who at that time was our sort of, partner, he just was our partner. And he understood in ways that were hard for other people to see, because that's their bread and butter, right? They're really high value data that they normally sold. And we said, hey, how about you give some of that away? And what's the upside of this? Well, the upside is you really do want to stimulate an innovative ecosystem of other developers who then ultimately, frankly, will monetize the value of your data, because your data's monetization is limited by what people can do with it. And the people who can do the most with it are not sitting in your company. And that conversation was one that was very effective, not the first time around, not the second time around, but through multiple engagements. That's what people don't understand, right? Technology advancement isn't just about tech advancement. It's about the relationships with people who are willing to take the risk with you. And I will say, in a nod to Todd Stavish, who's not here, he really worked that relationship along with myself and Tony and some of the colleagues at Digital Globe, and then Dave as well. So we sort of had a multi-layered relationship structure that has to be acknowledged. And it's really a testament to the team again. And, CosmiQ is special in part because you guys really put your egos aside. It's really about CosmiQ and the team as a whole and getting stuff done. And I think that's one of the things I hope that people take away from this experience, right? It's not just about the fact that you guys are some of the smartest people I know. it's also how you work collaboratively as a team and how you engage with others. And in that case, it was our first partner, Digital Globe, and then, to Ryan's credit, expanding that partnership over the years with other SpaceNet partners to broaden the data sets and all of that. So hopefully that gives you sort of a historical perspective, Adam, that you know, some of you may not have had, because I know some of you weren't there, but yeah.
Yeah, no, thanks, Lisa. It is fun to see how long it's lasted, right? And it, you know, when we first kicked it off, it was very much touch and go, and yeah, we got a lot of things right for sure. So why don't we just touch on a couple of the individual space nets, right? So you know, well, maybe you don't know, but we've talked a lot in past podcasts about previous space nets. So space nets 1 and 2 were buildings, space nets 3 and 5 were roads. We can say plenty about that, but let's not do that now since we've got people on the line. Why don't we dive a little bit into SpaceNet 4, which was a very unique collect. One that Dave Lindenbaum really helped start, but then Nick was the one who ran it and frankly really set a new bar within CosmiQ, and I think anywhere, for analysis of results. So maybe Nick, just a note on kind of what the motivation was and what was kind of the biggest takeaway from SpaceNet 4.
Yeah, definitely. That was as you said, a really cool and really unique set of collects where it's one of the only cases where you can get commercial satellite imagery taken at a whole bunch of different angles at more or less the exact same time of one location. And this was a series of actually calibration collects for the WorldView 2 satellite taken over Atlanta, where they took 27 shots of the city, from, you know, ranging from at nadir to I think 54 degrees off nadir, looking both north facing and south facing. And so getting to leverage that data from Maxar was really instrumental to being able to learn what we learned, which was that the look angle really matters. You know, we talk a lot about geographic diversity and seasonality and things like that in the geospatial realm, but one thing that we learned really well from that data set and that challenge was that if you train a model, you know, on a look that's 25 degrees off nadir, south facing, it's not necessarily going to perform that well on imagery of more or less the exact same location taken at, you know, I don't know, 15 degrees off nadir from the opposite direction. And it's really important to cover all of these different axes, you know, geographic diversity, seasonality, look angle, things like sensor resolution, really all these things that come from kind of the idea of the satellite imagery utility manifold that you, Adam, and Ryan and Dave, and really everyone on the team has scratched at from one angle or another over the course of our time at CosmiQ. So yeah, thanks for the opportunity to kind of mention that. And I agree, that's a great example that kind of specifically highlights how we can dig at one key feature of satellite imagery for computer vision.
The one thing I'd just add on to it is that just to your point, Adam, about one of the things that made SpaceNet 4 also unique was the sort of additional post-challenge analyses that Nick did. And, you know, and like a lot of things that end up getting legs and having high impact, there's whatever distribution you want to call it, there's a heavy distribution towards hard work and diligence, and then there is an aspect of luck. And I think one of the things that was more of luck, at least from my own perspective, was Nick was doing all this analyses on a really unique data set, which, you know, he was just talking about. And then it was really the first time that we also, as a collective, said we need to do more in terms of making sure that this content is getting out to the data science community, whether it be researchers or in the field practitioners. And this was something that Kristen, you may know her as producer Kristen on the show. She is one of our marketing leads inside of IQTEL. She had been asking us for a while on this. And the reason I highlighted it was a confluence of, us consistently delivering on multiple SpaceNet challenges with all of our partners, a unique data set, which Nick was talking about, plus the analyses, plus additional outreach. It was really the first time that we saw exponential growth in downloads or clicks across our blog post, the open data set, as well as our GitHub repo. And when I look at like kind of turning points for us, that we started this in 3, and we started getting an uptick, especially after the first roads effort, particularly from different groups in automotive. SpaceNet 4 is when we saw the first real exponential jump in downloads or views across all the different mediums that we had. And that really kind of led to, as you were insinuating, Adam, it kind of led to the model, which then came in place for 5, 6, and 7, and then any Cosmic project, as well as how we talk about things before we launch a project, how we release content once we have a project, and then certainly how we do the handoff, almost the tech solution transfer, if you want to use that term loosely, to the open source community after a project. And so, at least for me, that transition from 3 to 4, and certainly the analyses that Nick did after 4, was kind of a big turning point in terms of how we did business as an organization going forward.
Yeah, that's a very, very good point. So kind of leveraging a lot of that, right? Let's jump ahead to SpaceNet 6, which was unique in a lot of ways as well, right? It was our first data that was not Maxar. So Maxar was, obviously key for the majority. But SpaceNet 6 was, well, I think Jake and Daniel were really the only two to really live Cosmic rule for a long time, or Space Club rule, which is when in doubt, use SAR, right? So kudos to them for that. So why don't I kick it over to Daniel for a second? Daniel's, unlike the rest of us, he's very thoughtful when he talks, and so he's been quiet. But Daniel was key to this. Jake led SpaceNet 6, but Daniel did a lot of the kind of the SAR investigation. So Daniel, maybe just a brief note on kind of the intricacies of SAR, and anything else you'd like to mention about 6, and then Jake, you can maybe add at the end some of the notes about the final results.
Sure. So SAR is interesting to work with in that in some ways it's just like optical, in some ways it is completely different. And so that let us use a lot of the tools that have been developed for optical. Solaris played a very important part with SAR, with SpaceNet 6 in particular. But there were also just interesting novelties, like looking down at these images and seeing skyscrapers that appear to jut out into the middle of a canal because of the geometric distortions that you get with a SAR image. But I think what was really interesting with SpaceNet 6 was all of the different types of knowledge that ended up playing a part in making that happen. There was a lot of it that was geospatial analytics. There was a lot that was computer science. There was a lot of math. There was a lot of physics. And all of these different pieces played a role in it. And I think to be able to make it happen, given that context of all of this, it certainly helped a lot that the people in Cosmic come from different backgrounds in terms of education and work experience. But I think it also helped that this was building off of all the work that had come before it. We could not have done SpaceNet 6 at the level of quality that we did if it had not been preceded by SpaceNets 1 through 5. And I think that's true of every challenge in the SpaceNet series.
Yeah, great points, Daniel. Yeah, SAR really was our white whale for years in terms of we wanted to do a challenge using SAR data for a really long time. It's such a different domain that, as Daniel described, but it has real advantages in terms of the cloud penetrating abilities being one of the major ones, able to work at night being another one. So there's a lot of interest in what can you actually do with this data. And it was a similar problem to when we started SpaceNet, in the sense that there was no data available, particularly at very high resolutions. Thankfully, we ran into Capella Space. I think Nick reached out to them first, and they were immediately very interested. They had just collected this campaign, an aerial campaign over Rotterdam with one of their new sensors mounted on an aircraft, and they wanted to test what people could do with this data. So, after just really a few conversations, that they were super eager, handed the data over to us, and just like that, the white whale was dead. We had SAR, and we were able to run a challenge around it. And, this was really the first very high resolution data set in this X-band range that is openly available, openly licensed. Anybody can use it. So it was a great launching off point. So I think we learned a lot of lessons from the challenge, and learned that, computer vision really can be successfully applied to SAR data. And I think it's a great stepping stone for what's going to come down the road, because Capella just launched 2 more SAR satellites. We've got tons of SAR data coming down. If you want to check out our Twitter feed, it's gorgeous. It's beautiful. You can look at our SAR data whenever you want. But I think there's a heck of a lot of work to do in terms of analytics and SAR coming down the road.
Yeah, SAR has been really exciting. One real quick note on 7 before SpaceNet 7, before I think it's time to wrap up, which is 7 was interesting in that it was, I think, spoke to the success of SpaceNet in that we brought on a new partner, which is Planet, and tackled a new domain, which is time series. So I don't need to say anything about that, but again, I think it's pretty exciting to see the momentum that's been achieved with this model. So with that, we could go on reminiscing, but I think it's time to kind of wrap up. And so I could rattle off a lot of the wins that we've had both in SpaceNet and Cosmic, but I think probably more interesting is maybe just let people kind of pitch in on just kind of lasting impacts or fun anecdotes before we call it a day. So the floor is open.
I'll perhaps lead off, and I'm cognizant of the time. I want to make sure everyone gets a comment, but over the course of the years, or those who've listened to this podcast, you'll notice that we normally conclude an episode with a Space Club rule. One that I think is most fitting, or at least summarizes, I think, some of the core concepts discussed here, is Rule 35, which is stay on target. And whether it is some of the market analyses we're talking about, initial model development, data set development, or increasing participation in certain GitHub repos, whatever the topic was that we kind of covered, I think one of the core takeaways that I've had from this whole experience, one of the many, is that it can take time, right, to truly build something that has impact and actually starts to answer the questions that we want. And given the novelty of new technologies and the potential applications they have, there's such a demand or pressure sometimes for us to hurry up, get a result out, call it done, and kind of move on to the next thing. And while there are times that's absolutely necessary and you have to move that way, there is a lot to be said for trying to break piece parts down into their incremental steps. So when you do launch a data set, or when any of you have to put out blogs or papers, you can really stand behind it. And it's something that lasts the test of time. And that's certainly something that I take with me in my current work, as well as anytime I'm even tackling just a personal project at home. I have actually downloaded some of Jake's SAR data, and I highly recommend it. It's my wallpaper, Jake, so I think you'll appreciate that on my computer. That was for you. But the lesson holds true, is that breaking things down into their piece parts, being very diligent about it, is something that is a great lesson. And I think as a result, a lot of the work that we all did over the years, whether it's technical or business analysis, I think that's why it still holds up today.
I would just say, Ryan, that was really well said. And I think you've expressed exactly what I think is one of the lasting impacts that CosmiQ is going to have on In-Q-Tel, and then of course on the broader community. And that discipline approach to how we tackled problems, I think, is something that I'm very proud to have been a part of. And I think the other thing that's really special, has been special about CosmiQ, honestly, I mentioned it before, but it's a key to success in my experience. You can get a lot done as a small team if everybody on the team is empowered and plays to the strengths and feels that they can rely on each other and pull together. And so we tell all these stories now, and they're funny and humorous to us, right? But at the time it was hard, and we didn't know, right? When we said, okay, this is our line and we're not crossing it, you know, Adam, as you recall back when we were really struggling and establishing our principles of SpaceNet and how we were going to go forward, we didn't know how that was going to turn out. We didn't know if they were going to walk away, but at the moment we were there as a team. And we had each other's back. And I will say that those lessons hopefully are also just as powerful to all of you. I know most of you are a lot younger than I am, and you have long careers ahead of you. But I think the leadership that you've seen from Ryan in particular, as he pulled the team together, I think you guys, you know, we all joke and tease him a lot, but I think he's a really good exemplar of the way you lead a team, which is, you know, it's not about yourself. It's about what the team together can do. And for all of my experiences in my, you know, old career now, I have to say one of the things I still enjoy the most when I think back is my time with all of you. So thanks for indulging me today and inviting me to be part of this.
Yeah, I think another really cool thing about CosmiQ was just how interdisciplinary we were. All of the different backgrounds that really contributed to this. You know, Ryan's economics. We had astrophysicists, particle physicists, mathematicians. Nick has a bio background. I think I was the only person that had like a truly geospatial background to start. And but I think bringing all these different perspectives and experiences together ended up really helping us, because you could really break down a problem from a lot of different ways, and each of us learned so much from one another. So I think that really contributed to a lot of our success.
Yeah, I think something else that was really special about the environment we were in there at CosmiQ and at In-Q-Tel, and that you all are still in, is the ability to really pursue research and in a fashion that allows you to maintain your values. When you're talking about, we really think to do this right, you need to license the data this way. And the fact that at CosmiQ we were able to kind of stick to that. We didn't need to compromise on things like that. And I mean, the dividends that paid were really amazing. I mean, if you look at when we were in Korea presenting our SpaceNet paper at ICCV, the number of times someone from a startup company came up to me asking how the data was licensed, and to figure out whether they'd be able to use it or not to help them develop their products, which then of course they were going to buy more commercial satellite data to build and to deliver, was huge. And I think the fact that we were in an environment where we could make decisions about what we thought the best approach was going to be, whether it was developing a new metric that made more sense for satellite imagery data or licensing or whatever the topic might have been, and then the fact that we could stick to that was really instrumental to our success.
Well, thank you all for joining. This has been fun, at least for me, hopefully for everyone else as well. Hopefully it was somewhat cogent. It's hard to know, right? Too many trips on memory lane. But yeah, it's certainly been an honor to work with all these folks. We kind of mentioned at the start, right? This is the last podcast we anticipate. As of March 2021, In-Q-Tel is shuttering CosmiQ and stepping back from SpaceNet. But again, lots to be proud of. Lots that we've learned. I think lots that we've impacted. And at least for me, I think I can end on a Space Club rule that gives me some hope, which is Rule 33. And Ryan's already smirking. It's not over until it's over, and it's never really over. So let's leave it at that. Thank you all.